record.
Every dog in this dog shelter will get adopted. We are going to launch the biggest marketing campaign you have ever seen, and we are not going to stop until all these dogs find a home. But first, let me introduce you.
earphones. Fuck, Mr. Here.
Kwani hapa ni na pani yangu hivyo sio pani hapa na hapa.
Okay, Chebi, you should relax.
Excuse me.
All right, sorry for that. I think now I'm audible. You can hear me, right? Let me start again. I said I need to start with a recap of what you did with Mr. Onyango. And I would wish to remind us some of the issue that, or some of the topics that you learned with Mr. Onyango. Firstly, he introduced you organic chemistry. One, whereby we said organic chemistry is all about study of carbon compounds, but we are excluding the oxides of carbon and the carbonates. And more specifically, in organic chemistry 1, we will mainly deal with hydrocarbons. And I would wish someone to remind us what is an hydrocarbon, please. Someone to remind us what is an hydrocarbon. By raise up of your hand, can you kindly define an hydrocarbon, please? Yes, Mutie. Mutie, define what is an hydrocarbon, please.
A hydrocarbon are organic compounds made up of carbon and hydrogen only.
That's very good. Thank you. We said hydrocarbon are compounds which are made of hydrocarbons are compounds which are made of carbon and hydrogen only. That is carbon and hydrogen atoms only. And more specifically, you shall realize that we are grouping these hydrocarbons into 3 classes, depending with the kind of bond existing between carbon and carbon. And as you shall realize that for the carbon which have a single bond between carbon and carbon, we are calling them alkanes. That is a single bond. For the double bond, we are calling them alkenes. And for the triple bond, we are calling them alkynes. Those are the 3 classes of hydrocarbons that you shall be dealing with. And we also mentioned that hydrocarbons in which only a single covalent bond are present in the molecule are called saturated compounds. I'm repeating again. Hydrocarbons in which only a single covalent bond are present in the molecule are called saturated compounds. For the others with more than one covalent bond, that is for the alkanes and alkynes, we are calling them unsaturated compounds. You can note that if you didn't mention that. Hydrocarbons with a single bond, we are calling them saturated compounds. Hydrocarbons with more than one bond, we are calling them unsaturated compounds. That is just a recap of what you did with Mr. Onyango. We also talked about sources of alkanes, whereby we said one is crude oil. I'm very sure you processed it. The other thing is cracking of alkanes. And I need to emphasize so much on the cracking of alkanes. We are cracking longer chain alkanes. And for us to crack longer chain alkanes, we have 2 ways of doing so. One, we can use thermal cracking. The other thing, it is catalytic cracking. I need someone to distinguish between the 2, please. What is thermal cracking? Distinguish between thermal cracking and catalytic cracking. Thermal cracking and catalytic cracking. Someone to try. A different person from Moutier. Another person, please. Yes, Sami.
Thermal cracking involves the use of heat to break down the long chain alkanes to short chain alkanes, while catalytic cracking involves the use of a catalyst to break down the long chain alkanes.
Good. In both cases, you shall realize that. Can you unmute yourself, please? Mute yourself, please. You shall realize that for the thermal cracking, we are using a very high temperature to break the long chain alkane. For the catalytic cracking, we are still involving temperature, but relative low. But there is catalyst present in that case. So those are two ways of getting cracking long chain alkane. Then from there now, what we need to talk about is nomenclature. Nomenclature, you shall realize that the nomenclature is all about naming. Sammy, please. Okay, sorry. Now, in the nomenclature, it's all about naming of these compounds. And when you look at the members of alkane, we said they have a prefix A and E at the end, which are, in other words, we are calling it a surname. And more specifically, you shall realize that if you look at the first 10 members, let me just go through the first 10 members. The first member of alkane, it is methane. If you look at the last 3 letters, it is derived from A and E, which we are calling it prefix from the alkane. The second member, it is ethane. Ethane is all about getting the last 3 letters from the alkane. The third member, it is propane. The fourth member, it's butane. When it comes to 50 member, it is pentane. Remember, pent means 5. Then you add the prefix A and E to call it a pentane. So the number of these numbers we are talking about, if for example, in the first case of methane, we are talking of methane being member number 1. Why are we saying it is member number 1? The reason is because it has only 1 carbon. When we go to ethane, which is the second member, we are talking of it has 2 carbons. When we go to the third member, it is propane, because it has So the third member, we've talked about propane. Propane, because it has 3 carbons. When we go to butane, it has 4 carbons. Pentane, it has 5 carbons. Hexane, it has 6. Heptane 7. Octane 8. Nonane 9. And then finally, we have 10th member, which is alkane. So when you look at these members of alkane family, they are ending with word A and E, ane, because we are deriving it from alkane member. Now, that is what you did with Mr. Mang'u. Today, we would wish to start with isomerism. And when we're talking of isomerism, I need first to note this. Isomerism is the existence of molecules that have the same kind of atom. That is, they have the same molecular formula, but they have different structural formula. I'm repeating again. Once we are talking of isomerism, we are looking of some molecules with the same molecular formula, but they have different structural formula. Can someone distinguish between a molecular formula and structural formula? I think you defined this with the Mwalimu. Someone to distinguish between molecular formula and structural formula, please. I'm waiting someone to try.
Volume.
Yes.
A molecular formula shows the elements present in a compound, the proportion of the atoms in the compound, while structural formula shows how the atoms of different elements are arranged in a compound.
Good. Molecular formula, I need you to note this very keenly. Molecular formula, kindly mute yourself. Molecular formula shows elements present in a compound and the proportion of their atom in the compound. Structural formula shows how the atoms of different elements are arranged. So I can simplify this by saying molecular formula shows the elements present. Structural formula shows the arrangement of atoms, shows the arrangement of atoms. Now, for example, if you look at this member, like let me talk about alkane member 4. Alkane member 4, which is butane, which is C4H10. C4H10. This is the molecular formula of butane. If you need to look at the structural formula, we can either condense it or open the structure. What do I mean by condensing the structure? Let me start by opening it. We have 4 carbons, the first carbon, the second carbon, the third carbon, the fourth carbon. Each carbon has hydrogen. And remember the maximum number of bonds between carbon and carbon are 4. So this carbon has how many bonds? 1, 2, 3, 4. So hydrogen, hydrogen, and if you have another hydrogen there, this one has an hydrogen here, has an hydrogen here, has an hydrogen here, and a hydrogen here. Finally, still this one has 1, 1, 1. Let me confirm whether my formula is correct. How many carbons? 1, 2, 3, 4. How many hydrogens? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So when you look, my molecular formula, my carbon are 4, my hydrogens are 10. So I'm trying to open the structure of butane. This is how to open the structure of butane. The other thing, you can either condense the structure. How will you condense the structure? The first carbon has 3 hydrogens, so CH3. The second carbon has 2 hydrogens, so CH2. The next carbon still has, the next carbon still has 2 hydrogens, so CH2. Then finally, the last carbon has 3 hydrogens, so CH3. This is still structural formula, which is condensed one of butane. So that is now what you did with Walimu. Now, when it comes to isomerism, have a subtitle, isomerism of alkanes. Isomerism of alkanes. I need to define what is an isomer. Isomerism of alkanes. Kindly note, are compounds. Isomer are compounds that have the same molecular formula, but different structural formula. I'm repeating again. Isomers are compounds with the same molecular formula, but different structural formula. Isomerism, I'm defining isomerism is the existence of molecules is the existence of molecules that have the same molecular formula, but different structural formula. Isomerism is the existence of molecules that have the same that have the same molecular formula, but different structural formula. I think I'm clear up to that point. I need to show you an example of an isomer. An isomer. I have an example, please. I need to have the structural formula of butane. And please, before we continue, I need you to note this. Isomerism starts from alkane member 4. Isomerism starts from alkane member 4. Because if you look at the first member, let me have the structure of the first member. Have a look at this. The first member is methane. Methane is 3CH4. If you draw the structure of methane, it will be C, hydrogen, 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 and hydrogen. No way we can reposition the position of these carbons. When this is the structure of methane, C, hydrogen, 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 and hydrogen. When we go to member number 2, which is ethane, ethane has C2H6. The structure is C, C, hydrogen, 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 and hydrogen. This is hydrogen, 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 and hydrogen. This is the structure of ethane. There is no way we can reposition the position of this carbon. If we put it here, still we have the same kind of structure in that case. The same to propane. But I need to show you how the isomerism are formed, starting with butane. Butane is member number 4. The formula is C4H10. Let me start with the first structure of butane. C, 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 carbon, carbon, hydrogen, 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 and hydrogen. This is the normal structure of butane. Now, you shall realize that we have still 4 carbons and we have 10 hydrogens. The same butane can give us a different structure. How is it possible? I need to shift this carbon and attach it in position in carbon number 2. What will I have? I will have a structure like this. Carbon, carbon, carbon. I'm repositioning 1 carbon to that position. This becomes hydrogen, hydrogen, hydrogen. Still hydrogen here, hydrogen here, hydrogen here, hydrogen here, hydrogen, and hydrogen. This is 1. This is 2. This is still butane, remember. Butane having 4 carbons and 10 hydrogens. Have a look of this isomer of butane. Still we have how many carbons? 1, 2, 3, 4, right? Then the number of hydrogens are how many? Let me count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have the same molecular formula. Remember, molecular formula shows the number of elements present. But what about the structure? The structure is different. The structure is different, but we have the same molecular formula. So these are what we are calling isomers. Isomers is molecules which have the same molecular formula, but have different structural formula. You can have this one as an example of an isomer, please. Have an example of this. You can draw it after you have defined what is an isomer. Have this example. Draw the structure of butane. Then draw the second isomer. The other thing is the next step will be how shall we name? Because they don't have the same name. We are now coming to the nomenclature. How do we name the branched alkanes? Please have this one as an example before we move on. Have that example. Any question before we move, please? Any question? Kindly hurry up. I need to give you another example of an isomer. Pentane. Member number 5. C5H12. That's the molecular formula of pentane. Let me see how many isomers I can get from pentane. For the butane, we have seen we can only get 2 isomers. This one and this one. Let me see for the butane, so for the pentane, how many isomers I will get. Let me first open the structure. Carbon, 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 carbon. 1, 2, 3, 4, 5. Hydrogen, hydrogen, hydrogen. And you have a look of that is pentane. That's the structure of pentane. I need now to start repositioning the carbon. Let me shift this carbon, the last carbon, to carbon number 2. What kind of a structure will I have? Let me say this is the first one, the first isomer. I'll have C, 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 C. I'm repositioning the last carbon. All right. So this has hydrogen, 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 hydrogen. Let me count the number of carbons in the first structure. 1, 2, 3, 4, 5. How many hydrogens? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I have the same number of carbons and hydrogen. That is 5, 12. In the second isomer, let me count the number of carbons. 1, 2, 3, 4, 5. 5 carbons, hydrogen are still 12. Let me confirm. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Have a very keen look of those two. I can still get another isomer. I can still reposition this carbon and bring it still here. I will reposition this carbon to carbon number 2. What kind of a structure will I have? I will have carbon, 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 carbon. And remember, every carbon is surrounded by some carbons, some hydrogens, like this one. Have a look of this. This is the third isomer. This is the second isomer. This is the first isomer. So the most important thing to note is this. Isomer, they have their molecules with the same molecular formula, but the structure is different. How will you get a different structure? A different structure is obtained by just changing the position of these carbons. Now, what is now, we shall realize that the name of this is not the same as this. The name of this, the first, is not the same to this. It's not the same to this. And now that is now where we are coming to. How are we supposed to name branched alkanes? We call them the branched alkanes because you can see they have some branches. They have some branches. This is a branch. This is still another branch, a branch. So there is a way of naming these branched alkane. I'm only using a layman's language for you to understand. In other words, we call them the substituent groups, which we are calling them the branch groups. And for us to be in a position of naming them, I need to have a look of this. I need to have alkanes members. I need to mention 1, 2, 3, 4, 5, 6, 7. We say the alkane members, number 1, it is methane. The second member, it is ethane. The third member is propane. The fourth member is butane. The fifth member is pentane. Let me first reach there. Methane, ethane, propane, and butane. Then finally we have pentane. These are alkane members. If the first member of alkane is methane, which is CH4, if it happens that we remove a single hydrogen from alkane member, I'm repeating again, if we remove one hydrogen from alkane member, this one will have CH3. That is once we remove a single hydrogen. Once we remove, this one is CH6. When we remove a single hydrogen here, we shall have C2H5. This is what I need to say. When an hydrogen is removed from alkane, the name derived is alkyl. We get alkyl member. I guess I'm clear. When a single hydrogen is removed from alkane, we get alkyl member. That means if methane, a single hydrogen is removed from methane, we are now getting a methyl. The second member now becomes ethyl. The next one after removing a hydrogen, propyl, butyl, pentyl, hexyl, and so forth and so on. So this is how we are getting a name after removing a single hydrogen. Kindly you can note this. Kindly note this. If any hydrogen atom, attached to any middle carbon atom, I'm repeating again, if any hydrogen atom attached to any middle carbon atom is replaced is replaced by any alkyl group, a branched alkane is obtained. A branched alkane is obtained. A branched alkane is obtained. You can have this example. We have alkane, what we have mentioned, and alkyl group. I need you people to know what is alkane and alkyl. The first member, we've said, is methane with CH4. This one is methyl with CH3. Put an hyphen, please. Alkane, methane with CH4. You obtain, if we remove a single hydrogen, you have said we get alkyl group. So we have a methyl, which is CH3. Put an hyphen. The second one, it is ethane, C2H6. So we are getting ethyl, C2H5. Put an hyphen. Kindly continue up to the last member, the 10th member. The third one will be propane with C3H8. You are getting an alkylic group being propyl with C3H7. Kindly continue up to the last member. That's the 10th member. Once you are through, I'm giving you 3 minutes, and I'm waiting for any question before I move on. Kindly, if you have a question, raise up your hand. I'll give you time. If you have a question, please kindly raise up your hand. A very good question. Someone has asked this question. Why are we removing only one hydrogen? A very good question. I've said, if you look, for example, I have butane, C, 1, 1, 1, 1, 1, 1, 1, 1, 1, 3. Let me have an example of this. The question is, why are we removing a single hydrogen? We are removing a single hydrogen to get a branched alkane. I think you have noted that. And for us to get a branched alkane, we need to just remove one hydrogen, whichever way. Either we can remove this hydrogen and attach a branch here, or remove this hydrogen and attach another branch here, or remove this hydrogen and attach a branch here. Hydrogen, attach a branch. Hydrogen, attach a branch. So we are only removing a single hydrogen for it to give us a chance of attaching another group. That's why we are saying when hydrogen atom is removed from alkane, we are now getting another branch. And if an alkane misses one hydrogen, we are now getting this name. If it was a methane, we are getting a methyl. If it's ethane, we are getting an ethyl. So a single hydrogen is removed for us to give us a chance of attaching another group in that case. That's why we are calling it a branched alkane. Is that clear? Any other question, please?
Sure.
Please repeat that, teacher.
I repeat the branching.
Yes.
Good. Mute yourself. I need to repeat what I've said. This is a butane member. Why am I calling it a butane? It has how many carbons? 1, 2, 3, 4. How many hydrogens? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it has C4H10. This is a butane. If we need to attach a branch it's always attached to these bonds. And the bonds are attached to the hydrogens. We cannot have a branch between carbon and carbon. We can only have a branch between carbon and hydrogen. So this covalent bond, which is attaching the hydrogen, it is the only place we can attach our branches. That's why we are saying we can only remove a single hydrogen if we need to attach another group. Like for example, if it happens that I'm removing this hydrogen. If I remove this hydrogen, I attach another group here. I can attach as long as doesn't matter the length of the branch. I can attach that carbon, another carbon here. And remember, every carbon must have 4 bonds. So this carbon has 1. We have another hydrogen here, another hydrogen here on the other side, another hydrogen here on the left side, and another right side here. 1, 2, 3. 1, 2, 3. So we can only remove, once we remove a single hydrogen, we now get a very long chain branched alkane in that case. That's how we are talking about branching, removing alkane, and so forth and so on. So the idea here is, once an hydrogen is removed now, we will no longer have an alkane member, we shall have an alkyl member in that case. Is that clear now? Any other question? Any other question? Yes, Steve Collins.
So what if, can you remove more than one hydrogen to get another member? The way removing one hydrogen to get alkyl?
Yeah, we are coming to that. Please, we are coming to that.
Okay.
Good. Now, let me move direct to the naming now, the nomenclature. I'm sure now you are aware how to name alkanes. The first one we said is methane, second one is ethane, propane, butane, pentane, hexane, heptane, octane, nonane, and decane. Those are the alkane members that you mentioned. Now, I need to have the system, or to give you the nomenclature. We have some rules, which we are calling it the UPAC rule. UPAC rule. It is a system of naming branched alkanes. And for us to have, or for us to be in a position of naming branched alkane, we need to have the following rules. Kindly note them. Rules for naming. Rules for naming. Rules of naming. Rules of naming branched alkane. Rules of naming branched alkane. The first rule, rule number one. Rule number one, identify the longest continuous carbon chain. Identify the longest continuous carbon chain to determine the name of the parent alkane. Number one, I've said identify the longest continuous carbon chain to determine the name of the parent alkane. To determine the name of the parent alkane. For example, I have this. This is an example. This is an example of a branched alkane. This is the example of a branched alkane. Yes, Fred. Fred, you have a question?
I've already found the answer. Just
Sorry?
leave.
You are not clear.
The answer. Just leave it. I've found the answer.
All right. I have an example of this. Gary, I'm waiting. You have a question, please?
Cha, how did you form that that structural formula there?
Okay. I'm answering that right now. Now, I'm only giving an example. And the example is the example that I have right now, it is of this structure. Don't worry how I've formed this one. What I have, it is how many carbons? 1, 2, 3, 4, 5. This was one formed through isomerism. I think now I can now take you back to the isomerism of pentane that we had. Now, if you are given such a structure and you need to name this structure, I've said the first thing, it is to look for the longest continuous. Can you kindly underline the word continuous? We are looking at the longest continuous chain. The longest continuous chain, it is just formed by counting a long chain, leave alone the branch. Let me see. I think you can now see this example. Let me try to zoom it. Is it now visible?
No. Yes. Now it is visible.
Visible.
Yes, now. Yes, it is visible.
Have a look of this.
No.
This carbon,
It's not visible.
carbon number 1, carbon number 2, carbon number 3, 4, 5. All carbons I have here are 5. If I need to count the longest continuous chain, I will count it whichever way or whichever direction. 1, and let me count the longest continuous chain this way. 1, 2, 3, 4. Let me now reverse. 1, 2, 3, 4. I can as well count it this way. 1, 2, 3. I'm looking at the longest continuous chain. Leave alone the branch. 1, 2, 3. 1, 2, 3, 4. So I can see I can count, I get 3, other times I can get 4. So you take the longest continuous chain. So the longest chain is what? Now the longest chain becomes 4.
4.
They are 4, good. So if they are 4, let me number it. I can move in this direction. That will be 1, 2, 3, 4. All right? I can number them moving on my left. That will be 1, 2, 3.
They are not 5.
Why 5? Kindly read the first rule. Identify the longest continuous carbon chain, the one which is continuous. Ile mrefu, in other words. Those are saying 5. How will you get 5? Unaenda 1, 2, 3, 4, 5. That is not continuous. You look for the longest continuous chain in that case. So now we have agreed the longest chain is 4, not 5. So this becomes a branch. This now becomes a branch. It's not continuous, right? Now, the other thing that you look at is where is the position of your branch. Where is the position of your branch? When I move in this direction, my branch is in carbon number 2. When I'm moving on this other direction, my branch is position number 3. So I will take the list number. So the list number is 2. So I will say my branch is attached to position number 2. I've said the longest chain is 4. So that means the longest chain will give you the parent name. So I will say the parent name is 4, which is what? Butane. The first thing is to get the parent name. The parent name I've said is 4, which is butane. Rule number 2. Rule number 2. The rule number 2 we have said is looking for the position. I'll give you notes. I will give you notes, please. I will give you notes. Rule number 2 is to look for the position of your branch. I've said my branch is position number 2. No. And what the kind of branch do we have? The branch that we have is this branch.
But I'm almost finishing.
This branch is not a methane. This branch is not a methane because you know methane has CH4, but mine is lacking 1 hydrogen. So it will be a what? Someone to try? What is the name of your branch?
Methyl.
Methyl.
The branch will be methyl. Position what?
2.
Where is the position of the methyl?
2.
Good. Position. 2. I need now to have one name. The name will now be, you start with the position 2, you put an hyphen, you have the name of your branch, and it should start with a small letter. Methyl, butane. And it's one word. The name of your branch, the name of this compound, it is 2-methyl butane. Butane is the parent name, methyl is the branch, 2 is the position. If you need to name this structure now, that is the simple ways of naming it. First, look for the parent, look for the branch, and look for the position. Am I now clear? Any explanation, further explanation that you need? Can we move on with the rules so that
have
we
a
have
question, sir.
Please.
Excuse me.
Yes.
What if there are like
Yes,
two
Manu.
methyls on different branches?
A very good question. I'm answering that right now. What if we have two or more?
Yes.
Another question? Another question?
Yeah, a question.
Yes.
Teacher, what if you count the structure from the left? That
What if you count?
it comes to position.
It becomes?
It comes to position 3.
It becomes position 3, yeah? So it will be 3-methyl butane,
Yeah.
right? But what we are saying is that we look for the least number possible, right?
Okay.
You use
Yes.
the direction that will give you the least number possible. So the least number is 2 or 3?
2.
Good. Another question? Another question? Okay, let's continue with the notes. I've said the first rule, we are writing the rules. The first rule I said, identify the longest continuous carbon chain to determine the name of the parent name. For example, have example of that structure. Have an example of this structure and give us the parent name is butane. The longest chain has 4 carbon. Here's the name, the parent name is butane. Kindly have an example, right? An example for you to understand. Draw this structure. I'm in the first rule. Then say the longest chain has 4 carbon atoms. Hence the parent name is butane. Hence the parent name is butane. Rule number 2. Number the longest chain. Number the longest chain from the end of the chain. Number the longest chain from the end of the chain that is near to the branching. That is near the branching. For example,
please repeat.
Number the longest chain from the end of the chain.
Nearest.
Number the longest chain from the end of the chain that is near the branching. For example, we are still using the example that you have drawn above. For example, in the above structure, numbering should start from left. Numbering should start from left. Numbering should start from left. That is, now you can have the number 1, 2, 3, 4 from your left. Therefore, carbon 2 of the longest chain, therefore, carbon 2 of the longest chain, carbon 2 of the longest chain has a substituent group, of methyl, has a substituent group of methyl. Has a substituent group of methyl. So now you can now give me the full name of that structure. The full name, we said it is 2. You put an hyphen, methyl, and then M is a small letter M. Butane is one word. Methyl butane is one word. Methyl butane is one word. Is that example clear?
Yes. Yes.
Yes.
Yes.
Yes.
Yes.
Yeah.
Yes.
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 No.
Yes.
Yo, it is clear, yo.
Maurice. Okay, now we need to have another example. Example 2. I need to have a different structure. The structure that I have is this kind of a structure. I need to have this structure. Is it visible?
Yes.
Yes.
No.
Okay.
Yes.
I think it's not visible. Yeah? Look at this.
Yes.
Look at this example.
Yeah.
You mute yourself. This example, the first thing is to look for the parent name.
Anyone can get it.
Someone to give me the longest chain.
Anyone can get it.
3.
Three.
Yes.
Let's count it together.
Yes.
1, 2, 3. 1.
Yes.
If you as well you count from your right, it can still be 3. 1, 2, 3. Or 1, 2, 3. Or 1, 2, 3. Whichever direction will give you 3. So long as giving you the same, now what you'll now look at is the side that will give you the least number of your branches. So the least number is just the same. The position will still be 2. So that means if the longest chain is 3, the parent name is what? Someone to give me the parent name?
Propane.
Propane.
Propane. Now, how many branches do we have?
2.
2.
Two.
Which branches are these?
2.
2.
Two.
Methyl.
Methyl.
2.
This
Yes.
is a methyl.
Methyl.
See, this is a methyl.
Methyl.
Right? So we have
Yes.
2 methyls.
Methyl.
We agree on that.
Yes.
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 Did we note this? Mute yourself. You cannot be quiet. The position is position 2. We are all in position 2. All right? This methyl is position 2. This methyl is in carbon number 2. Now, because we have 2 branches, which are methyl, 2 means di. So the name now becomes, we have 2 methyl. So they are 2, we shall call them the dimethyl. Dimethyl. Now we join the position. The first methyl is in position 2, so it shall have 2, comma, 2, di methyl propane is 1 1. 2, 2, because this methyl is in position 2, the other one is position 2. 2, 2, dimethyl propane. 2, 2, dimethyl propane. Is that clear? 2, comma, 2,
please
dimethyl propane.
dimethyl
That
Yes,
becomes,
get you.
Yes.
if we add 3 branches of methane, if we add 3 branches of methane, we could have tri. Tri means 2. 4 means what?
Take from the left. This should start O in from the left.
Tetra.
Tetra, good. If branches are 2, they become di. If branches are 3, they become tri. If branches were 4, they become tetra. So we have now, as we are saying, di. And we have rule number 3.
Okay. The method here. 2.
One, two, 3, 4. Wananamba from there to the 2, 3, and na ungaleka kwa 2, 3, 2, 3,
Before I move on, I need to be very clear on this example. If you also count from your right side, let me have a different pen. Maybe this becomes let me count from here. This will be 1. This will be 2. This will be 3. I'm counting this way. The longest chain is still 3, which is propane. My branch now becomes this branch. This is the other branch. So they are still in position 2. And the longest parent name is now propane. So the branches are still 2. 2, 2, dimethyl propane, which still have the same name. So long as you are getting the list number of where the position of your branches will still give you the same thing. And that is what you are getting at that point. Now, I need now to give you, write down rule number 3. Rule number 3 states this. In case there are 2 or more, in case there are 2 or more similar substituent groups, in case there are 2 or more in the chain, they are indicated by the prefix. They are indicated by the prefix di.
Pardon.
Because there are 2 or more similar substituent groups in the chain, they are indicated by the prefix di for 2, tri for 3, tetra for 4. Di for 2, tri for 3, tetra for 4. Then you continue that way. Commas are used to separate the numbers. 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 That's why you are seeing I'm putting a comma between, we put a comma to separate the numbers.
What if the substituent groups are not similar?
But if the substituent groups are not similar, that is the rule number 4. I'm coming to that, right? Good.
What are substituent groups?
Sorry?
What are subsistence groups?
The substituent groups are what we are calling the branches. Right?
Yes.
Good. I need to give you one question for you to try to see whether we can now, or to see whether we are moving together. Have a look of this. Let me first write it. Let me try to name this. Draw this structure and try to name it. Draw this structure and try to name it using the 3 rules that I've given you. Sorry?
We're not seeing the whole thing.
It's not clear. It's not clear. It's not clear.
It's not clear. It's not clear, teacher. It is not.
Now it's clear.
Yes.
Yes.
Be very keen with the branches that I have. Try to name it.
Can't see it.
Sorry?
It's not visible.
I see it's not clear.
I've got the answer.
Let's wait for the others, please. What is the answer? Someone to try? Let me give you a chance, Duncan.
Two, three
Duncan.
dimethyl pentane.
Sorry?
Two dimethyl
Three
dimethyl pentane.
dimethyl pentane. That's very good. And this is how we are supposed to write it. 2, 3 dimethyl pentane. Those who got 3, 4 dimethyl pentane. I'm very sure that some of you got 3, 4. Those who count from their rights to lefts, you got 3, 4. But we are looking for the least number. If you sum the two, these are for the more than 2. If you sum the 2, this will give you 7. If you sum this one, this will give you 5. You look for the least number. You look for the least number. So the least number is 2, 3, not 3, 4. So we are counting from left. We are counting from left to right. And the correct name, it is 2, 3 hyphen dimethyl pentane. That's the correct name. That's very good. I need to give another example. Example 2. Let me draw another one. Just a minute. I have an example of this. I have an example of this. I hope it's clear. Yes, Michael. Michael, you have a question?
Not sure, no.
It's not clear. Try this example. You are to kindly give us the solution for that. I'm waiting for the solution. Someone to try. Someone to try. In Con, we are waiting you. Gary. Give us the solution.
3-methylbutane.
3-methyl?
Butane.
No. The parent name is wrong. Someone else? The longest chain is not 4. Yes, Duncan? Duncan? Duncan try. Sammy?
1,3-dimethylpentane.
1,3-dimethylpentane. No. Duncan? Let's look for this. Let's just go through the question together. The longest chain is what? The longest chain?
Let me answer.
Okay.
3-methylhexane.
3-methylhexane. Very good. 3-methylhexane. 3-methylhexane. The longest chain is hexane. Can we count together from bottom? 1, 3, 4, 5. My example is very clear, right? 1, 2, 3, 4, 5, 6. Where's the branch? This is the branch. You count the longest continuous chain, the longest continuous chain. This is longest continuous. The branch is position 3. So the name becomes 3-methylhexane. I need to give you some questions for you to try on your free time. This is the assignment. Only 3 questions. Draw these structures. Are they clear? This is the assignment. Question number 1. I've said the answer for that question was 3-methylhexane. 3-methylhexane. This is the assignment. I'm giving you 3 questions for you to try on your free time. Make sure you can answer this before we continue next time. Have these 3 questions, please. Write, name each of the following. Name each of the following. The first one is this one. You have 3 questions. Kindly draw the structures. I need to repeat how I got my solution. Have a look of this. Have the look of this. I'm looking for the longest continuous chain, and this is how I numbered my structure. Position number 1, you can see it. This is the position number 2, 3, 4, 5, 6. The longest continuous chain, it is 6. So the parent name is hexane. Where is my branch? I'm only seeing only one branch, which is 3, position 3. And the branch is a methyl. That's why I say it is 3-methyl hexane. 3-methyl hexane. I'm referring to the first rule, the longest continuous chain. The longest continuous chain, it is 1, 2, 3, 4, 5, 6. The branch, it is methyl, position 3. Combine them, we shall have 3-methyl hexane. I think is now clear. The assignments that I'm giving you is this one. I'm sure you have now written them. Only 3 questions. Kindly name them. Name these structures, draw them and practice to see whether you can be able to name them. Any question before I end the meeting? Any question? Brian, James and Michael, you have questions?
Yes, teacher. When are we?
Sorry?
When will we get the answers to this assignment?
Make sure before Friday you are through with these questions. We shall start by naming them to see whether we are correct, and then we mark together, right? Kindly make sure before Friday you are through with those questions. Any other question? Thank you for your participation. I really appreciate so much. Have a nice time. Make sure kindly you have tried those questions on your own. Thanks so much. Have a nice weekend. Bye.